Today we're going to talk about balancing chemical equations. Chemical equations must show something called the law of conservation of mass, which states that in a chemical reaction, the mass of the reactants must equal the mass of the products. Now, another way of looking at that is the number of particles when you start the reaction must be the same as the number of particles when you end a chemical reaction. You can't start with 5 atoms of hydrogen and end up with 4 atoms of hydrogen. It doesn't work that way. They must not change in amount throughout that chemical reaction. So we have to do something called balance the chemical equation. A balanced chemical equation shows this. The number of atoms of each element is the same on both sides of the equation, and that's what must be true. Now, we use subscripts, remember, to show the formula for a compound. So we'll write something like H2O, and that subscript 2 shows us that there are 2 hydrogens. And then for oxygen, since there's nothing after it, it's understood that there's only 1 oxygen in that formula, in a molecule of water. So that's what we use to write the formulas. Those cannot change when we balance a chemical reaction. If they do, we've changed the substance. And we'll see what I mean by that in just a moment. Coefficients are what we're going to use in order to balance chemical equations. Coefficients are numbers that are placed in front of a chemical symbol or formula to indicate how many atoms or molecules of the substance are involved in the chemical reaction. Now, when we put a number in front of a variable in the chemical equation, it indicates that we have, in this case, 3 A's. If we do this, it indicates that there are 3 A's and 3 B's. So it multiplies by everything inside those parentheses. And that's the same thing we're going to do when we put a coefficient in front of something, for instance, like water. What this means is that whereas originally there were only 2 atoms of hydrogen, now we're going to multiply, and I do mean multiply, by the 3 in front. So now what this tells us is that there are 6 hydrogens, but with that understood 1 after oxygen multiplying out, it tells us we also have 3 oxygens. So we need to keep that in mind, that that coefficient in front stands for everything in, multiplies by everything in that compound. So let's get started balancing some of these equations. The first thing I'm going to ask you to do is to, on every single one of your examples, for you to put a line or bar in front of the formula. This is going to help you to make sure that when you balance this, that you don't try to put numbers someplace where they don't belong. So we're going to put a blank. Whoa, that just moved that everywhere. Let's do this. Let's try this again. A blank in front of all these. And this is going to show us the only place that we're going to be able to put coefficients in these chemical reactions. So I'll continue that as we move down the page. So the first thing we also want to do then, after we put those blanks in, is to remember that that arrow stands for, in this case, we're going to make it an equal sign. And we're going to use that as an equal sign. And there should be the same number of particles on each side of the equation. So right now, if you'll notice, we've got 2 hydrogens here and 2 hydrogens on the left-hand side, so that's good. But look at the oxygens. We've got 2 oxygens here, but only 1 oxygen on the other side, and we've already shown this example of water up above. So we don't have a balanced equation. We don't have the same number of oxygens on both sides. Now, don't do this because it's incorrect. Let's say I put a 2 after this so that I could balance, in my mind, make the number of particles of oxygen equal on both sides. Well, unfortunately now by adding a subscript to this, we may have made the number of oxygen atoms equal, but we have completely changed the formula of that compound and changed the identity. H2O is water, however, H2O2 is hydrogen peroxide. And hydrogen peroxide and water are not the same thing. They may look alike, they may pour alike, but they do not taste alike and they do not act alike whenever we put them in our mouths. We cannot write that and change the number of particles by putting a subscript into the formula. The only thing we can do is put a number in front. So what I'm going to do is put a 2 in front. And what that 2 does is multiply by the oxygen. So now I have my 2 oxygens on this side. And I have 4 hydrogens now. That helped out my oxygens. I got my oxygens balanced with the other side, but look at what happened. Now with those 2 hydrogens, I'm unbalanced again. So what I'm going to need to do now is to put a 2 in front of that formula. And when I do, remember it multiplies by the subscript. So now I do have my 4 hydrogens on the left-hand side. So that is a balanced chemical equation. And now what I want to do is to look at all of these and write something that's called a coefficient list. And any blank that has nothing in it is an assumed 1. So my coefficient list here, reading from left to right, is going to be 2, 1, 2. And that's going to balance that chemical equation. Now let's look at the next one. The next one, we have on this side 1 cobalt. And by the way, I'm going to write that in green because you don't have to write that part. And I'm going to block this in green because I'm not going to make you write that part of it either. Some of you are going to be able to balance by inspection just by looking at it. And I'm going to allow you to do that on these problems. But some of you will want to write down these numbers of particles underneath. So right now I've got 1 cobalt and I've got 3 bromines. And I've got 3 sodiums and 1 phosphorus. On the other side, I've got 1 cobalt, 1 phosphorus, 1 sodium, and 1 bromine. So moving from left to right, which is what I do, my cobalts are good. I've got 1 cobalt here, and I've got 1 cobalt over here. My bromines, however, are not. I've got 3 on the left-hand side, but only 1 on the right-hand side. So what I'm going to do is to put a 3 in front here. I can't put it as a subscript. It would change the identity. I can only put numbers in those blanks. As soon as you do that, change what you've got written down below. That means now I do have my 3 bromines. I'll also have 3 sodiums. So now that I have my 3 sodiums, looks like my sodiums are good. I've got 3 sodiums on the left and 3 sodiums on the right. And now 1 phosphorus on the left, 1 phosphorus on the right. It looks like I have a balanced chemical equation. Everything is equal on both sides. Now my coefficient list, reading from left to right, all those empty blanks are going to be 1. So 1, 1, 1, 3 is going to be my coefficient list. So now I'm going to move this up now. Let's go on to the next couple. See if you can do the next one yourself real quick. Pause it and see if you can figure out how to balance this equation. So if you look at this, hopefully you did that. So if you look at this, right now we've got 1 potassium and 1 iodine and 2 fluorines. And on the other side, we've got 1 potassium, 1 fluorine, and 2 iodines. So that's what I've got so far. Looking at left to right, looks like my potassiums are good right now. However, my iodines are not. I've got 1 iodine on the left, but 2 on the right. What can we do to fix that? Well, the only thing we can do is to put a 2 in front of this. Now think about what that does when we put a 2 in front of that. It changes both the K and the I. So now my K's are not balanced anymore. I've got 2 on the left and 1 on the right, so it looks like we're going to need to put a 2 in front of the KF. Always change what's below when you do that. Looks like now I've got 2 Ks and 2 Fs, which very nicely looks like that balances my fluorines as well. So this reaction is balanced, and my coefficient list would be 2, 1, 2, 1. Try this next one yourself as well. Make sure you put the blanks where they belong. Make sure that it's a little more complicated. So if you can do this one, you can do any of these ones that don't contain polyatomic ions. So try that. So hopefully you did try it, and hopefully you put your blanks in first, showing where you could put coefficients to balance this. Let's go ahead and figure out how many we've got on both sides. We've got 1 iron and 2 oxygens on the left, and we've got 2 irons and 3 oxygens on the right. We've done this kind of work many times. Right now, it looks like with our 1 iron on the left and our 2 on the right, right now let's put a 2 in front of that iron, which is going to change just this below to a 2. And now that I've changed that, it looks like my irons are good, but my oxygens are not. I have 2 oxygens on the left, but 3 on the right. Now, what can we do with a 2-3 combination? We can switch them. It looks like the smallest number that both of those two will go into evenly, both 2 and 3 will go into evenly, is a 6. And if that's true, it looks like I'm going to need to multiply the oxygen over here by 3, switch those around, and the Fe2O3 over here by 2. Now change everything that changes right away. That gives me 6 oxygens. That gives me 4 irons. It gives me 6 oxygens over here. So now my oxygens are good, but it looks like I messed up my irons in the process. If I've got 4 over on the right, I need 4 on the left. So it looks like all I really need to do over on the left is to switch out that 2 with a 4. And when I do, that's going to change this number down here to a 4. That doesn't look very good, but it's supposed to be a 4. Now it looks like everything's balanced, so my coefficient list ends up being 4, 3, and 2. But now what if a reaction ends up having a polyatomic ion? Look at the ones up here that have polyatomic ions in here. The best thing you can do for yourself is to circle any polyatomic ion you find. Just the polyatomic ion. And on these first worksheets, I'm going to require you to do that. Just the polyatomic ion. If it's in parentheses, don't circle outside the parentheses, just circle the polyatomic ion. And my strong suggestion then is to put a 1 outside that, because we have 1 of each of those polyatomic ions in there. Those 4s and 3s you see, remember, are part of the polyatomic ion. We're going to treat these as a whole, just as one thing. We're going to treat PO4 as just phosphate. There's 1 phosphate on the left, 1 phosphate on the right. So when we write this up, this is how we're going to do it. When we show underneath it how many of everything we've got. We've got 3 sodiums, we've got 1 phosphate, we've got 1 silver, and we've got 1 nitrate. We've got 3 silvers on this side and 1 phosphate. And we've got 1 sodium and 1 nitrate. Got carried away with my parentheses there. I don't know if I can draw this in. It's not right in exactly the right spot. So again, 1 nitrate here. So when I look across here and start looking at this for balancing, I've got 3 sodiums here, but it looks like I've only got 1 sodium over here. The first thing, make sure you've drawn in those blanks, because that's the only place I can put any numbers. So if I need to balance out my sodiums, looks like I'm going to need to put a 3 here. Now make sure and go down below and change everything that changed. It changed this to 3 sodiums and 3 nitrates multiplying. So now my sodiums are good, looks like, at least for right now. So let's go on. We've got 1 phosphate on the left and 1 phosphate on the right, so that's good. 1 silver on the left, but 3 silvers on the right. So how can I fix that? The only thing I can do to get more silvers is to put a 3 in front in that blank, and that's going to change stuff. Remember, it changes it to 3 silvers, and it also changes it to 3 nitrates. So my silvers are good now. My phosphates, my silvers are both good. How about my nitrates? I've got 3 nitrates on the left and 3 nitrates on the right. So looks like I'm balanced now. So my coefficient list is going to be 1, 3, 1, 3. See if you can do the next one real quick. The way we just did it, it's a little more complex. See how you do with it. So hopefully you did that. I'm going to draw in the blanks in the front for the only place that we can put coefficients. And what did I say to do first? Circle those polyatomic ions. Remember, we're only going to circle what's inside the parentheses. So we've got now, and this only works if the polyatomic ion is on both sides. So circle those polyatomic ions first. And now let's go through and figure out what we've got. It looks like on the left we've got 1 tin and 4 chlorates, 3 potassiums, and 1 phosphate. If you want to, remember, you can go up here and put 1s after these that don't have anything after them. Keep that in mind. On the right-hand side, we've got 1 potassium, 1 chlorate, 3 tins, and 4 phosphates. So that's what we've got over here on the right. So starting left to right, I've got 1 tin here. I've got 3 tins over here. So how can I fix that? I'm going to put a 3 in front of this tin. Now make sure you change everything that got changed when I did that. It changed it to 3 tins. What did it change the chlorates to? 12. Changed it to 12 chlorates. So looks like my tins are good now, but my chlorates are not. Looks like I've got 12 chlorates here. I've only got 1 chlorate on the other side. So what am I going to have to do to fix that? Yeah, I'm going to put a 12 in front of this. Change whatever we just changed. That's going to make this a 12. It's also going to give us 12 chlorates. So my chlorates are good now. And let's see what comes next is so we've got our chlorates good, 3 potassiums, 12 potassiums. How can I fix that? The only way I can do that is to multiply this by 4 to get my 12 potassiums. So that's going to change this to 12 potassiums. It's also going to give us 4 times 1, 4 phosphoruses. So that balances the potassiums, and what did it do? Well, it very nicely gave me balanced phosphates as well, 4 on both sides. So the coefficient list for this is going to be 3, 4, 12, 1. Okay, and the last thing we want to balance are our combustion reactions. They can be notoriously difficult to balance because they often have large coefficients in front of them. So there's a trick to this, and I'll show you what that trick is in just a minute. First, draw your blanks. Okay, we've got to be careful because this is a situation, we have oxygens everywhere, and we really have to pay attention to the fact that there's more than one place where oxygens are located on the right-hand side of the equation. So let's just start with what we've got. With this, I feel like it's better to just balance it without writing everything below it, because we'll you should try it. I think you should try it like this now that we've seen and gotten kind of used to it with those other kinds of problems. So let's just go from the left-hand side. We've got 4 carbons here. We've only got 1 carbon here. So the first thing we're going to do is to put a 4 in front of this carbon. Okay? And let's look at what happens when we do that. We have our carbons balanced. Okay, the next thing that I want to do, I want to save oxygens for last. So you always do carbons first and then go straight to your hydrogens. I've got 8 hydrogens over here, and I have got 2 hydrogens over here. So the next thing I'm going to do is to put a 4 in front of here to get my 8 hydrogens. Now here comes a little more difficult part. Now is where we want to balance the oxygens, and this boils down to the fact that we've got to add up those oxygens in both places. We have 4 times 2 here. That's going to give us 8 oxygens here. We've got 4 times 1 here. We've got 4 oxygens here. How many is that total? We've got 12 oxygens total. Over here we've only got 2, so it looks like we're going to need a 6 in front of those oxygens in order to get that balanced. So it looks like our coefficient list now is going to be 1, and I guess this should have been in blue, 1, 6, 4, 4. So that's going to balance that particular equation. Now there's a glitch that can happen in these problems. Let's look at the next one. We'll start out the same way. Carbon first, then hydrogen. So it looks like we've got 2 carbons over on the left, but only 1 carbon on the right. So the first thing we're going to do is to put a 2 in front of that CO2. And that's going to give us 2 carbons. Go straight to the hydrogens. Remember, carbons first, then hydrogens. Looks like I've got 6 hydrogens here, only 2 over here. So it looks like we need a 3 in front of this, in front of the water, in order to get our 6 hydrogens. The next thing we need to do is to count up our oxygens. Carbon, hydrogen, then oxygen. Remember, multiply that 2 in front by the 2 at the end. That gives us 4 oxygens here. The 3 times the 1 at the end for water gives us 3 oxygens. That's a total of 7 oxygens. Now, what's the problem? Over on the left, we have 2 oxygens. There's nothing we can do to balance our oxygens, because if we put a 3 in front of this, we have 6 oxygens, and that's not enough. If we put a 4 in front of it, we have 8 oxygens. That's too many. When you have odd oxygens, and you might want to make a note of this off to the side, if oxygen is odd, double everything. Double everything you've just done. That includes the very beginning, not this oxygen that's on the left, but at the very beginning, we're going to need to double that. We're going to double this 2 here to a 4. We're going to double the 3 to a 6. Think about what that does. That is going to double this to an 8, double this to a 6. Everything's doubling. Double this to a 14. And what can we do now? If there are 14 carbons on the right, we can put a 7 in front of this 14 oxygens on the right. We can put a 7 in front of the oxygens on the left, and we now have 14 oxygens on the left. So if oxygen is odd, double everything. So that gives us 2, 7, 4, 6 for our coefficient list for this one. Okay, do the last one yourself real quick. See if you can get this one. Do the same thing we just did. Hopefully you did that. So we're going to draw our blanks in front. We're going to We do carbon then hydrogen again, so we need 5 in front of this carbon to match our carbons on the other side. Since there are 10 hydrogens on the left, we're going to need a 5 in front of this water to get our 10 hydrogens when we multiply. And now remember, we add up our oxygens. We've got 5 times 2, we've got 10 oxygens on this side. 5 times the 1, we've got 5 oxygens on this side for a total of 15 oxygens. And that is not going to work because we have odd oxygens. If we have odd oxygens, remember we double everything. So I'm going to go back in. I'm going to change this to a 2, multiply. I'm going to multiply 5 and change by 2 and change that to a 10. Multiply this 5, change to a 10. Multiply this to a 20, this to 10, and this to 30. And this is what I've got to match now. And if I've got 30 oxygens on the right to get 30 oxygens on the left, I'm going to need a 15 in front of this oxygen to do that. So that ends up giving me a coefficient list of 2, 15, 10, and 10.